All right, we've been doing a lot of linear equations, and we're going to continue that by doing a few more point slope examples, especially on graphs. All right, so how do we find a point slope equation from a graph? Well, first let's remember what our point slope equation is. So right here we have y equals m, or slope, times x minus x sub 1 plus y sub 1. And this y sub 1 could be at the beginning here, and that's okay as well. So let's take a look at our graph and how we're going to write this equation. Well, first of all, I have 2 points, so I can find my slope with these 2 points, right? So I have 1, 2, 3, 4 as my rise, and I have 1, 2 as my run. So slope is rise over run, so I have 4 over 2, and 4 over 2 is simplified just to be 2. Now remember, x sub 1, y sub 1 is a point on the line. So go ahead and just choose one of these points. So I'm going to choose this point right here. And that point, it looks like, is 3, my x value. And 1, 2, 3, 4, 5 for my y value. So that point is 3, 5. So x minus 3 plus my y value, which again is 5. So there's my equation in point slope form. Now this is estimate the y-intercept, right? So if I estimate the y-intercept, this doesn't cross the y-axis in the graph that I have right here. So I'm going to kind of continue that line down until it does cross the y-axis. So it looks like it crosses at a negative, right? So this maybe is, so here we have 1, 0. Looks like maybe it crosses at negative 1.5. So y maybe is about negative 1.5 or negative 3/2. I'm putting this using improper fractions. But let's convert this to slope-intercept form to see if our y-intercept, or our estimate for our y-intercept, is close. All right, so first I'm going to distribute. So 2x, then 2 times negative 3, so negative 6 plus 5. All right, so now I'm going to simplify by combining like terms. So I have 2x, I have negative 6 and a positive 5. If I combine a negative 6 and a positive 5, I'm going to have 1 negative left over. So my slope-intercept form is y equals 2x minus 1. So my estimate was a little bit off, right? Because it's hard to estimate when you're just looking at a graph and you're having to do some guessing. So slope-intercept form, converting to slope-intercept form gives us an exact y-intercept. Now I want you to remember that a y-intercept right here, right? What is the value of x at that y-intercept? In other words, what's the ordered pair here? X would be 0 and y would be negative 1. So my ordered pair is 0, negative 1. So I want you to remember that at the y-intercept, x equals 0, right? So again, really important, at the y-intercept, x equals 0. So we're going to use that information here. All right, so this is the graph from a second ago, same exact graph, same thing we did. Again, the y-intercept is where a line crosses the y-axis. In other words, x is 0 at the y-intercept. So what we haven't talked about yet is the x-intercept. So an x-intercept is where a line crosses the x-axis. So up here for the y-intercept, x equals 0. So for the x-intercept, then y must be 0. So again, this is really important. At the x-intercept, y equals 0. So let's take a look. I'm going to write down the equation that we found. So we have y equals, and we said 2x minus 1 was our slope-intercept form equation that we found for this graph, right? What if I said, what is the x-intercept? Well, I can see the y-intercept. The y-intercept is negative 1. I don't see an x-intercept here. There's no way of just looking and seeing the x-intercept. But remember, y equals 0 at the x-intercept. Really important, y equals 0. So if I want to find my x-intercept, well, I could just substitute 0 for y. Because wherever y is 0, that's where my line is going to cross the x-axis. And so let's look at where it looks like it crosses the x-axis right about here, right? So it looks like my y-intercept is about 1/2. or sorry, my x-intercept is about 1/2. It looks like it crosses right there. Y is 0, x is 1/2. That's my estimate. Let's check that to make sure. So again, y is 0 at the x-intercept. So I'm going to substitute 0 for y. So 0 equals 2x minus 1. Now if I want to find out what x is alone, I'm going to have some undoing to do. So I'm going to add 1 to both sides. And 1 equals 2x. Finally, to get x alone, I'm going to want to divide by 2 on both sides. So I end up with, once I divide by 2 on both sides, 1/2 equals x. So it looks like we were correct with our estimate for that x-intercept. Let's try a couple more examples. So here I have an equation in slope-intercept form. And again, to find the x-intercept, y is going to be 0. So 0 equals 4x plus 3. Okay. I want to undo this equation. So what I'd like you to do is pause for a moment right here and find what x is. So check your answer with mine. This is what we should have gotten for our x-intercept. So it looks like our x-intercept is negative 3/4 when I substitute 0 for y. So let's try one more. So here we have point slope form, and we need to turn that into a slope intercept first before we find our x-intercept, right? So we could do that. We could take, okay, 2 times x, 2 times -2, and use our distributive property. On the other hand, is there a shortcut? Remember, now we just need to substitute 0 for y, right? So could we do that without using our distributive property first? If I just enter in a 0 here, substitute a 0, I have 2 times x minus 2 plus 10. Could we just simply undo this equation without our distributive property? Oops, excuse me. Wrong values, x minus 2 plus 10. Right, well, let's see if we can do some undoing. Now, since this is in parentheses, I'm going to leave this together, right? So it looks like the last thing that happened here was to subtract 10. So I'm going to undo that by adding 10. So if I add 10 to both sides, I end up with 10 equals 2 times x minus 2. Okay, we're doing things a little bit differently this time, so just make sure you're following along. All right, so again, x minus 2 is in parentheses, so I'm just going to leave that as is. I'm going to treat that as one thing. So this whole entire thing right here was multiplied by 2. So to undo that, I'm going to divide that whole thing by 2. All right, so I'm going to get rid of that 2 here. And now I have 10 divided by 2 is 5. And over here I have x minus 2. So pause here, finish it up, and see what you get for your x-intercept. So it looks like this time our x-intercept is 7. In other words, that line, we graph this line, it's going to cross our x-axis. Let's say there's my 7 on my x-axis. It's going to cross that x-axis at the value 7. All right, let's do one more example of an application here of point slope form. So in this problem, Alex collected this table of data by using 2 thermometers simultaneously. He suspects that one or both of the thermometers are somewhat faulty. So he recorded one temperature in Celsius, so that's going to be our x value, and he recorded one in Fahrenheit, which is going to be our y value. So I'm going to go ahead and put this data into my calculator. Now remember, to do this, pull this up here. To do this, I'm going to go to Stat right here. I'm going to edit. So I've gone ahead and put my values in my lists already. So go ahead and pause and put the values in your lists on your calculator. Again, Stat and edit, and here are your x values, and here are your y values. Now I want to go ahead and see that on a graph. So this is going to be a scatter plot. So make sure right here where it says Stat Plot, Make sure that you have one of your scatter plots on and everything else is off. And then I'm going to go ahead and put graph. Now, if yours isn't showing up, remember, you can go to Zoom and hit number 9, and that'll give you a good window to see your data. So this is the data from the table of values on the right. Right, so our next step is to find a line that fits this data. So give me 2 points on here that look like they would create a good line to fit this data, to find a line of best fit. Well, to me, it looks like this point up here, this point down here. If I were to draw a line through the data connecting those 2 points, would that give me a good line of fit? It looks like it might go through the data pretty well. So I'm going to choose this point, which looks like it's the lowest x value. I'm going to choose this point, which looks like it's the greatest x value. So let's look back at our data. All right, so it looks like the least x value, so that lowest point was this one right here, and the uppermost point was this one right here. So I'm going to use those two values, or those two ordered pairs, 14.5 and 55, as well as 31.2 and 88.6 to find a line. Now I have 2 points, which means I'm probably going to want to use point slope form, right? But before we use point slope form, we need to actually find a slope. So I'd like you to pause right here and use these two ordered pairs to find a slope for this line. All right, so I found my slope to be about 2. It's about 2.01. I'm going to round that to 2. So I'm going to take my slope and I'm going to choose one of these points. Let's just choose the top one. And I'm going to write this in point slope form. Right? So y equals m is 2, times x minus x sub 1. I'm going to choose the top point, so x sub 1 is 14.5, plus y sub 1, and in my top point, my y sub 1 is 55. So here's my equation in point slope form. All right, so now what I want to do is I want to see if this equation actually fits the data on my graph. So I'm going to go back to my graphing calculator, and I'm going to type that equation into my graphing calculator. Right, so I'm going to go to y equals, I'm going to type that right in, so 2 times x minus 14.5. Oops, x is right here, x minus 14.5 plus 55. All right, so again, I'm just going to go to graph. And there's the line from the point slope equation that we just wrote. Now, does that line look like it fits the data? Well, it looks like I have 3 points below the line. I have 2 points above the line, and I have 4 points almost right on the line. That looks like a pretty good line of fit. Now, if I had a line that started down here, and let's say went through a couple points but ends up this way, it's not a good line of fit because I'm going to end up with a lot of points below the line. So you got to be really careful about the points that you chose. So we chose this bottom point here and this top point here. And that fit the data really well. If I were to choose, say, this point right here and this point right here, my line would have gone more like this, right? Which would not have fit the data very well. It would not have followed the trend. So be very careful about the points you choose to write your point slope equation.